So this is the fifth video in a series on work and integration and calculus. And so in this video, I'm going to talk about particularly hydrostatic pressure, and that is defined as the amount of pressure or amount of, it's related to the force of a standing body of water exerting on some object, for instance, a dam, or you can think about a bathtub. If you've just got standing water, static water, or any liquid for that matter, sitting in a container, how much force, how much pressure is being exerted on the walls of that object. And so the standard unit measure of pressure is called a Pascal, and 1 Pascal is 1 Newton per square meter. And so that's actually force divided by area, which is equal to 1 kilogram per meter times second squared. And so before I get into all those steps, I'm just going to go ahead and start looking at my example, which says I have a dam in the shape of a trapezoid. So let me go ahead and start drawing myself a trapezoid. I know that the height of this trapezoid is 20 meters. I know that the bottom of this trapezoid is supposed to be 30 meters wide, and the top is supposed to be 50 meters wide. It also tells me in the problem that the water only goes up to 4 meters below the top of the dam. So there's my 4 meters below the top. So I actually have 16 meters deep of water behind this dam. And so what I need to do now is look over here at my steps. So I'm going to draw a y-axis in the vertical direction parallel to gravity and choose a convenient origin. Now, one of the things I want to point out is I'm going to actually use this y-axis to split the top and bottom in half. So I'm going to just kind of come in and draw my y-axis like this. So my origin splits it in the middle. So there's 15 meters on the left, 15 meters on the right at the bottom, and 25 meters at the top, and 25 meters on the right side at the top. So there's my origin, that dot there. And the next step is to say, if AB represents the vertical extent of the liquid, we usually make A equal to 0. I'm going to say most of the time. So in this case, it starts at the origin from 0 and goes all the way up to 16 meters. That's how deep the water is. And the next thing, I need to identify the density of the liquid rho. So in this case, we're using just water, so 1,000 kilograms per cubic meter. And that's something that, again, they typically give to you. It says for y values between A and B, find the cross-sectional width of the horizontal slices. So for example, if I was at the bottom of this dam, it was 30 meters all the way across. So if y is 0, our width, W of y, should be 30. If we were all the way at the top of the dam, which the water isn't currently, it would be 20 as our y value and 50 as our width. And so that's kind of the question in this situation is how can I incorporate the y value, that height, in telling me what the width is? Now, if it were a rectangle, it would just be a number. But since this is a trapezoid, it's changing. So for example, if this were at the 10 meter mark, 20 meters is 25 meters on each side. 0 is 15 meters on each side. If I was at the 10 meter mark, I would expect this to be 20 meters wide on each side, so 40 meters total. But so probably the best way to do this, I would think, just personally, would be to make a linear equation for this side. So if I can figure out what this line right here is, then I can kind of use that as my y values and figure out how my width is changing based off of that. So what I'm going to do is I'm actually use this point here at the bottom, which is 15 for x, 0 for y, and I'm going to use this point up here at the top, which is 25 for x and 20 for y. And I'm going to make a linear equation out of that. So y minus y over x minus x gives me 20 over 10, which is 2 for my slope. So my linear equation is going to start off y equals 2x plus b. I'm going to plug in one of the points. Let's do the 15 comma 0. So 0, 2 times 15 plus b. So that's going to give me 30 plus b equals 0. So b has to be negative 30. So that means my equation in terms of x is 2x minus 30. I do want it in terms of y because that's my height. So we'll do y plus 30 equals 2x. Divide by 2 gives me 1/2 y plus 15 equals x. And right now I know that that means that's this equation right here. So x equals 1/2 y plus 15. Now that's only going to give me 1/2 of the width. So my width is going to include the left side too, not just the right-hand side, but the left-hand side. So it's going to be 2 times 1/2 of y plus 15, which is the same as y plus 30. Now there's the width in terms of y. The other thing I need to worry about, step 5 says Find the horizontal distance or depth of the water of that particular horizontal slice. So for example, if my y value is down here at 0, my depth is 16. If I'm up here at the top where y is 16, I want my depth to be 0. So the best way to write this equation is d of y equals 16 minus y. And let me go back and kind of use that logic again. When my height is 0, when I'm on the x-axis down here, I want the depth to be 16. 16 minus 0 is 16. When I want to be at the top of the water, my depth is 0, and so my height was 16, so 16 minus 16 is 0. Let's say if I'm halfway in the middle of the water, so this is 8 meters, then I want to be able to plug in and say it's 8 meters deep. If I'm down here at a height of 4 meters, it should be 12 meters deep, so 16 minus 4 gives me 12. So it kind of makes sense that way. Now I'm just going to go ahead and start plugging into my formula. So the force exerted on this dam is going to be from 0 to 16 of my density, which is that 1,000 kilograms kilograms per cubic meters, times 9.8, that's my gravitational constant, 9.8 meters per second, times my width, which was y plus 30, times my depth, which was 16 minus y dy. Now I can multiply that together and take it out, which should give me 9,800. And we're integrating from 0 to 16. I know that y times y is going to give me y squared, but it's negative. That's going to be a positive 16y and a negative 30y, so that should give me negative 14y, and 30 times 16 should be 480. So all I did was FOIL out that width and depth. I'm going to go ahead and start integrating and keep that 9,800 out front. So that's going to be negative 1/3 y cubed. That's going to be minus 7y squared because 14 divided by 2, and plus 480y from 0 to 16. Now, if I plug in 0, I'm just going to get 0. So the only thing I really have to worry about here is plugging in the 16. So I'm going to go ahead and do 9,800 times negative 1/3 of 16 cubed minus 7 times 16 squared plus 480 times 16. I'm going to go ahead and plug all that into the calculator. So negative 1/3 times 16 cubed minus 7 times 16 squared plus 480 times 16. That's going to give me, oh, that's a fraction, 9,800 times 13,568 over 3. And if I multiply that by the 9,800, I'm going to get a decimal. I'll write that down. 443221333.33, which, let me see how many, if I write this side of addition, 1, 2, 3, 4, 5, 6, 7. So that's 4.4 times 10 to the 7th. And this is measured in newtons. So that's going to be my final answer, is 4.4 times 10 to the 7th newtons. Or you can write that whole decimal out. That's fine too. Again, I know this was a lot to go over. If you have any questions, please feel free to let me know. Hopefully this does help you guys better understand how to do this stuff. Have a great day.